This is the third section of Chapter 1, Algebraic Expressions, and this section is all about factorising. Now, factorising is just putting an expression back into brackets, whether that's a single bracket or double brackets, but there are a few things that we want to look out for. So, first of all, are there any common factors? So, are there any common factors which you can take out and put in front of a bracket? Now, a common factor may be a letter, a common letter that's in every term, or a common factor number that's in every term, or it could be both. You could find both a letter and a number, which is a common factor, which can go in front of brackets. Secondly, is it the difference of two squares? So if we notice it's an expression that's a difference of two squares, then we can factorise it using that method. So difference of two squares is a single bracket where you see something squared. It may be a single letter or it may be a letter and a number. So something that you can find the square root of, something squared minus something else squared. Now when you recognise this pattern, difference of two squares, DOTS, then it's going to be x plus y, or the first thing, the square root of the first thing, plus the square root of the second thing in the first bracket. The second bracket is the same two terms, but it's going to be a negative sign between them rather than a positive sign. So we'll look out for the difference of two squares and use this quick and easy method here to factorise those types of things. Or we want to look out to see, is it a quadratic that will factorise into two brackets? And be showing you the method I use to factorise things into two brackets. Example 6, we want to factorise 6 expressions completely. So we'll start with part A. We've got 3x plus 9. So here I'm looking for a common factor. What is a factor of both of those terms? And it's the number 3. 3 goes into 3x and 3 goes into 9. Now I need to work out what to put inside the bracket. So one way of thinking of it is, what do I need to put in the bracket? So when it gets multiplied out, I get 3x and I get 9. Well, the first term needs to be x, because I know if I do 3 times x, I get 3x. Then the second term in the bracket needs to be plus 3, because when I expand that and I multiply it, that will give me 9. Or another way of thinking of it is, what do I get if I divide each of these terms by 3? 3x divided by 3 is x. 9 divided by 3 is 3. Part B, I have x squared minus 5x. So I'm looking for a common factor. This term, the common factor is a letter, and that letter is x. So x goes into both terms. And then I can think of this as, well, what do I need to put inside the bracket? So when I multiply it out, I get x squared. So I need to put x there. And what do I need to multiply the x by to get minus 5x? That's minus 5. So minus 5 in the brackets there. Or another way of thinking of it is, what do I get if I divide both of these terms by x? X squared divided by x is x. Negative 5x divided by x is negative 5. Moving on to part C, we have 8x squared plus 20x. So we're looking for common factors. Now, I need the highest common factor of 8 and 20, largest number that goes into both, that's 4. Also, x is a common factor of both of these terms as well. So 4x will go outside the bracket. If we put 2 outside the bracket instead of 4, it's not going to be fully factorised. We want the highest common factor. And if I don't put the x outside the bracket as well, again, it won't be fully factorised, because I basically want the largest factor, the highest common factor of both terms, and that's 4x. So what do I need to put in the brackets for this to multiply out correctly? I want 2x as my first term in the bracket, because 4x times by 2x will give me 8x squared. Plus, because there's a plus sign here, what do I need to multiply 4x by to get 20x, and that's 5. Now you know it will be fully factorised because the terms that you put in the brackets will not have a common factor. if I ended up with terms in this brackets that had a common factor, so let's say, for example, both of these numbers could have been divided by 2, or they both had x's in, I then know it is not fully factorized, and I need to go back and check my what I've put outside the brackets. I'll show you what I mean. So if I did, by mistake, I had put 2x outside the bracket. I thought 2 was the largest number that could go into 8 and 20. Then I would have 4x as my first term here. So what I'm doing in green here is incorrect. This wouldn't be fully factorized. And then plus I would have 10 here. Notice 4 and 10 have got a common factor of 2, and that common factor of 2 should have been put outside the bracket, so that would not have been fully factorized. So we want to make sure we've got those highest common factors. Moving on to part D, we have 9x squared y plus 15xy squared. So let's see what we've got as factors. Well, factors, highest common factor of 9 and 15 is 3. How about the letters? Well, the highest x term that goes into both is x. X goes into this x term and the x squared. And with my y is also a common factor of both terms. It goes into y and y squared. In my brackets, I would have 3x. So 3xy times by 3x gives me the 9x squared y plus, and I would need to multiply 3xy by 5 to get the 15. X, I don't need to multiply by anything. I don't want it going to a bigger power, but I do want y squared, so this will be 5y. Now, whenever you're not sure, just multiply out the brackets and check to see that you get what you started with. And the last one, e, to e up here, I have 3x squared minus 9xy. So on this one, I can see that I have a common factor of 3. So 3 goes outside the bracket. And also both terms have x in them. So in the brackets, I would need to multiply 3x by x to get 3x squared minus 3 to get 9 and y to get the y at the end of that term. Again, we can always multiply out the brackets thus to check. So each one of these now is fully factorized. Useful check is just to expand the brackets to see that you get the expression that you started with, and also check that no terms in the brackets have a common factor. Example 7. I've got some quadratics here to factorize, and I'm going to be using a different method for each of these. Now, A and B, there's going to be one method that I use, and these are ones where the number in front of x squared, or the coefficient of x squared, is 1. So these are going to require one method. This one here, where the coefficient, a number in front of x squared, is not equal to 1, is going to require a different method, and I'll show you the method that I use for that. And D and E, they fit a pattern, and we're going to be using that pattern to factorize these last two. We always want to do these questions using the quickest and most efficient method. So we'll start with A, which is x squared minus 5x minus 6. Now, when we have a quadratic like this, where the number in front of x squared is 1, it's just x squared. First thing we want to do is to look at or highlight the two numbers, which are the number in front of the x and the number on its own here. So -5 and -6. And what we're looking for are two numbers that multiply to give you that number at the end, and add to give you that number in the middle. So we're trying to find two numbers that when we multiply them together give us -6, and when we add them together give us -5. Now, we always start by writing down the pairs of numbers that multiply to give us -6, because there's only a finite set of those numbers. We're not going to start by trying to find the numbers which add together to give me -5, because there's an infinite set of numbers that do that, and we haven't got an infinite amount of time to answer these questions. So these are the numbers that multiply to give me -6. So that could be 1 and -6. That could be -1 and 6. That could be 2 and -3. Or it could be -2 and 3. And out of those set pairs of numbers, I want to find which pair, when I add them together, give me -5. There's only going to be one pair that do that, and that's the first ones. If I add together 1 and -6, I get -5. So that's the pair I'm interested in. The other pairs, they don't add together to give me -5. Now that tells me which two numbers to put into my double brackets. So because it's a quadratic, it will be double brackets like this. The two numbers that I put in the brackets are 1 plus 1 and -6, and it's done. I can check to see if this is right by expanding the brackets. I'll do a quick check. So x times by x is x squared, x times by -6 is -6x, plus 1 times by x is plus x plus 1x, and then plus 1 times by -6 is -6. So I can collect the two terms in the middle, x squared minus 5x minus 6x plus 1x minus 6. So I know that's correct. So an expansion of the brackets is a useful check to show that you've got the correct answer. So that's the first one. When we do B is going to be done in a very similar way, because it's the same type of quadratic, one of these ones where there's not a number in front of x and we've got three terms. So we've got x squared plus 6x plus 8. So I'll start by highlighting the number in front of x, the coefficient of x, and the number on its own. And I want two numbers that multiply to give me +8 and add to give me 6. Now with practice you'll get these numbers quite quickly. So two numbers that multiply to give me +8. So I'll write down the numbers that multiply to give me 8. So that's 1 and 8, 2 and 4. Now they could also be negatives. So it could be -1, -8, -2, -4. So they could both be positive or both be negative. I want them to add up to give me 6. So that's going to be the +2 and the +4. So that tells me what to put into my double brackets. So x is going to go at the beginning of both brackets, and I will put +2, +2 and +4. Again, we could expand the brackets to check to see whether I've got the right factorisation or not. Moving on to C, we're going to use a different method here. And the reason we need to use a different method to what we've done before is because of this 6 here in front of the x squared. If we tried using the method we've just done before, we'd get the wrong answer. So 6x squared minus 11x plus 10, minus 10. So this is the method that I use. Step number 1, I'm going to multiply the first number and the last number. In other words, I'm going to multiply the coefficient of x squared with the number that's on its own. So I need to work out 6 times by -10. That gives me -60. Now what I'm looking for are two numbers that multiply to give me -60 and add to give me -11. So I'm just going to put a little cloud around those so I don't lose these numbers. So similar to the last one, but before I find those two numbers that multiply to give me a number and add to give me a number, I need to multiply the first and the last number first before I do that. Now I could have done that in all the previous examples, multiply the first and the last number, the number in front of x squared and a number, but all you're doing is multiplying it by 1, aren't you? If I did 1 times by 8, I just get 8. So it's the same type of method, but in the previous ones in A and B, if I multiplied 1 by the number, it makes no difference. But here it does make a difference. Now, there are lots of different ways of multiplying numbers to get negative 60. I'm not going to go through all of them. So we need to think smartly about which pairs of numbers multiply to make 60 or negative 60, and which pair I could combine to give me 11 or negative 11. So there's no point writing down 1 and 60, because there's no way I can combine 1 and 60 to make 11. Or there's no point using 2 and 30, because I can't combine those in any way to make negative 11. I could combine them maybe to make 32 or 28 or negative 28 or negative 32, but not 11. So we need to be thinking about factors where the difference between the factors of 60 are 11. And I'm thinking of 4 and 15. 4 and 15 multiply to make 60, and the difference between these two numbers is 11. So I could use them to make negative 11. Now, how am I going to do that? Well, I need to make this negative 15. Negative 15 and positive 4 makes negative 11, and they multiply to make negative 60. So those are going to be my two numbers. So the method I use is now I'm going to write at the beginning of both brackets 6x, because I have 6x here. Just like in the previous examples, because I had x squared, I wrote x at the beginning of both brackets. Then I'm going to put the two numbers in, plus 4 and minus 15. Now, if I just left it like this would be incorrect. What I now do is I'm going to cancel down each bracket. I'm going to look at each set of brackets that I've got and work out whether I can divide all the terms in each bracket by number. Now, the first bracket, I've got 6x plus 4. I can divide both of those terms by 2. Let's do that. I would have 3x plus 2. So that's cancelled down. Second bracket, I can divide both of these terms here by 3. 3 is a common factor. So I'm going to divide it by 3. And if I do that, I will get 2x minus 5. I've now finished. I have factorised it. I can expand the brackets to check whether I have factorised it correctly. You can do that if you want. So this method, slightly different to the previous one, multiply the first and last number, which we did. Find two numbers that multiply to give you that number that you just calculated, and the coefficient of x, the number in the middle. We did that. Those were the numbers 4 and negative 15. You put the numbers 4, plus 4, negative 15 in brackets. At the beginning of the brackets, because this is 6x squared, you put 6x. Now, if this was, I don't know, 8x squared, you would put 8x at the beginning of brackets. But we're not quite finished. What we need to do is to cancel down each bracket. So you look for a common factor in each bracket, and then you divide by that common factor. So the first bracket, 2 was a common factor, so I divided it by 2. Second bracket, 3 was a common factor, divided by 3. And here we have our final answer, 3x plus 2 in one bracket and 2x minus 5 in the other bracket. Moving on to D, we have x squared minus 25. Now this is the difference of two squares. We have x squared here and we have 5 squared here. So this is x squared, and this term is 5 squared. So when we recognize that, that means the quick way of expanding this, or factorising it, is whatever the two things squared are, we put in brackets. So it's x squared and 5 squared. And you put a plus sign in between the first two terms and a minus sign between the other terms, and it's factorised. It's done. We always want the quick, easy way. Next one, 4x squared minus 9y squared. Now this is also the difference of two squares, because 4x squared is 2x squared, 2x all squared. 9y squared is 3y all squared. When you recognise them, use them. So this will become, in brackets, 2x plus 3y in the first bracket, and the second bracket, same two terms, but with a minus sign, so 2x minus 3y. There we go. So again, you could expand the brackets as a check to see whether you have factorized this correctly. Example 8. We need to factorize each one of these expressions completely. Now on these ones, I notice that every term has an x in it. So that can be taken out as a common factor straight away. It may require further factorization, but the first step in factorizing is noticing, right, x or x to a higher power is a common factor. Now on the first one, x squared is a common factor. X squared goes into x squared goes into x cubed. So we don't want to just put x outside the bracket. That would not be fully factorized. We put x squared. So I would need x as my first term. That would multiply it to give me x cubed. And then minus 2, that would multiply it to give me negative 2x squared. And that one is now fully factorized. You can always expand the brackets to check. And also check there should be no common factors between terms in the bracket. When we did the previous ones, I think on part C, that method, before we finished, there were common factors, and that's when we simplified down, wasn't it? That was on example 8, part C. Part B. So I have x cubed minus 25x. So x can be taken out as a common factor. In the brackets, that would leave x squared minus 25. Now we're not finished, because what we've got here is the difference of two squares. So this can be factorized further. So the x will remain outside the bracket, and then we have x squared and 5 squared. So this will now factorize to be x plus 5 in one bracket, and then x minus 5 in the last bracket. I could put another set of brackets in like this, but it's not needed because it's all multiplication, so that extra brackets are not needed there. And C, again, I notice every term has an x in it, so the first thing I'm going to do is to take the x out as a common factor. So x will be taken out, and in the brackets I'll have x squared plus 3x minus 10. Now we may not be finished, because we need to see whether this can be factorized, what I've got in the brackets here. This is not the difference of two squares. The coefficient of this is 1, so I'll just put a plus sign here and a times sign here. I'm looking for two numbers that multiply to give me negative 10 and add to give me positive 3. Now I could write all of those multiplications out, but let's think. It's going to be 1 and 10, but I can't combine 1 and 10 to make 3. 5 and 2, yes, 5 and 2 can be combined to make 3. So 5 and 2. How can I combine them to make 3? By having a 5 and a minus 2. And those two will multiply to make negative 10. So 5 minus 2 does add together to make 3. So that means I can fully factorize this by putting x plus 5 and x minus 2. So that now becomes fully factorized. So when you see a common factor, then you can take that outside of the bracket first, and then what's left may then require further factorization. So you should now be able to do exercise 1C, which is on pages 8 and 9 of the textbook.